afternoon, fancy meet computers. How is everybody today? I see we have 30 people concurrently viewing. 35. Very good, very good. Maybe I should equalize the intro music to the like in-lecture music, or in-lecture sound volume, so it isn't such a big adjustment. Is that a bit better, guys? It looks like that might be a little better, like relative to the relative to me speaking. I'm doing well, thank you. That's the problem with adjusting your microphone. Let's see here. Slides. We were on expressiones. And we were going to finish that today. Here we go. Oh, thank you. So, do you guys all have a test or something today? This seems like a lower number of people than usual. I suppose, like, actually, you know what? I never actually, like, surveyed the class to see, like, what faculties y'all are in. Let me see. What faculty are you in? I only get 4 options here, so if you're not on this, just stay, like, list it out. Let's see. Commerce. Science. Let's see, I think health science, there's a fair number, and math. There we go. Econ 1BB3. Yeah, I think that, like, it seems to me that the commerce people have made this course like a prerequisite for one of their sub programs or something, like a specialization. So that is probably, I imagine there's probably a fair few commerce people in the class, but I just spent 1.5 hours writing a logical equivalence proof. Oh yeah, that. Oh, you only spent 1.5 hours writing it. Sockseye, yeah. It's just recommended for data. Yeah. Well, you know, programming is the it is the process of the manipulation of computerized data. So, does ArtSci count as a faculty? Yeah, I think ArtSci is definitely its own faculty. It's like, you know, a small one with a lot of cross-listed courses. But actually, you know David the TA, he's ArtSci, if I'm getting that correctly. Humanities, nice. Oh, the humanities. Chemical and physical sciences, yes. Oh, I think that chemical and physical sciences would be under the heading of science in general. But it seems like the class is about 60% scientists. So, hello, scientists. Yeah. Yeah, you arts and sci guys, like, I have a beef with you. I have a beef with your faculty. Apparently, the whole idea of starting the winter semester a week later than you should was your idea. And it means that poor people like me who have to teach summer courses have to, like, do the exam and then 2 days later start lecturing for the summer, you know? So it's like, sigh. But, you know, you guys do get occasional like, you guys are pretty smart. Like, I have nothing against... I think, like, it's really interesting. Like, the ASCII program is interesting in general, and I really think there's absolutely a place for, like, that kind of more liberal education in the university. It's just, I wish that you guys hadn't done that to me. Rah! But, yeah, that's okay. I'm not actually angry at any of the students. I'm angry at your administrators. Yeah. Life science, yeah. Hummers. Isn't math and stats under the Faculty of Science? Yeah, but they, you know, math might be a department of science, but, I mean, I'm pretty sure they have their own suit color, so there you go. Art Sci never showed up as an option for faculty in every survey given. Yeah. Oh, and MedRad Sci is another one. It's like medical radiation science, I believe, is its own faculty actually. I could be wrong about that, but I'm pretty sure they get their own jumper color. Like, that's kind of how I do faculties, because like I'm a person who you know, I remember the old days when we were actually on campus, you know, and everybody, you know, the engineering is the red suits, and the humanities is the navy blue, and commerce is green, and science is the black lab coats, and all that kind of stuff. And I'm pretty sure that MedRad Sci is like its own thing. Pretty sure. And it's like, I'm pretty sure it's a very, very small like number of students in it, like maybe like definitely less than 30, but yeah. I'm planning to change my program from commerce into computer science. It's so hard. Yeah, well, welcome. Welcome to computer science on behalf of computer scientists, of which I am not. Oh, you're purple? Oh, cool. Ha 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 ha. Okay, but like a nice lilac, or like a magenta. Like, what kind of purple are we talking about here? Violet? A violent violet? Anyway, we should probably talk about the lecture material, eh? There you go. There's an icebreaker for you almost a month into the class. Okay. All right. Engineering. Oh, that's interesting, actually, because, like, technically speaking, shouldn't you be taking the first-year engineering programming course? Nevertheless, welcome, engineering student, from a person who was also formerly an engineering student. ERTW. So, Coolio. Minoring in computer science. Oh, yeah, okay. But, like, technically speaking, this, like, you shouldn't be taking this course. If you're in this course, I'm not going to kick you out, but, like, it seems like it would overlap a lot with your first year Python course that you took. It's a long story. I believe it. It's a pretty normal purple. Okay. Anyway, doesn't matter. So, last time we were talking about various aspects of programming, like the basic stuff, like what a Boolean is, how to write comments, how to work with variables, and what operators do. We were talking about functions, however. And hopefully you guys are already fairly familiar with functions, because you guys had to be handing in assignment 1 over the weekend, so you'll have written a bunch of functions yourself at this point. So there's really just one technical point that we want to point out with respect to functions before we go on to the cool stuff, and that is functions don't. So you may have a certain amount of confusion between normal mathematical notation and function notation. So imagine you have two variables, x and y, and let's say you wanted to make z 3 times x plus y. The problem that you run into is it says int object is not callable, and that is an error that will shut your code down. So what's going on here? Well, It turns out that in programming speak, when you have an identifier or an object name that immediately and directly abuts an opening parenthesis, there you go for all of you people in computer land, it considers that a function call regardless as to whether the thing in front of it is a function or not. That's the syntax for a function call. So basically what it's saying here is that int object is not a function. 3 is not a function. And I agree, 3 is not a function. So just keep in mind that while in algebra that means multiplication, in computing you have to just put the multiplication symbol in there explicitly. Good. So, my goodness. So let's talk about data structures. So for some of you guys, especially if you're sort of new to programming, this will probably be the first reasonably big difficulty spike in the course. It's super, super, super important that you come to terms with the idea of data structures. Like, this is, again, highly fundamental, and not just because we load up the assignments in this course and the tests with a bunch of questions about data structures when they aren't really used. In fact, the use of data structures is extremely fundamental to your programming skill in general. But yeah, so what is a data structure then? It's really quite simple in concept. All you're doing is you're taking a bunch of variables, collecting them together and giving them one name, and being able to access them numerically via an index, as if you were to line them all up and say, okay, you're 0, you're 1, you're 2, you're 3, you're 4. And then when you say, I want data structure at index 4, it kind of goes in and grabs element number 4 and gives it to you. The big hang-up with data structures in general is that in computing, we use a model called zero indexing. So rather than the first element of any data structure being 1, the first, this element is not element 1. This is element 0. This is element 1. And there are extremely good reasons that computers do it that way. That you will learn if you study like lower level languages like C. But it goes right at the core of it. The reason for it is the manner in which the computer stores memory. And it's not like, it's such a fundamental fact about computers and the way that they store memory. You'll find pretty much every single programming language that you ever use will use zero indexing over 1 indexing, unless it's like explicitly gone out of its way to use 1 indexing instead of 0 indexing. But this is like a very, very common pitfall that a lot of people have. So this is called a tuple. We're going to study 5 different types of data structures in this class of varying usefulness. Tuples, I would argue, are not the most useful data structure. The most useful data structures in order, I would say, are lists, strings, dictionaries, tuples, and sets. But tuples are very they're basic, and we can get into it with them. They're essentially equivalent to lists, but they're not mutable. We'll talk about what mutability is later. So, a tuple is a collection of objects. So if I have a tuple, it can be 1, 2, 3, 4, 5. There we go. The way that you get at the individual elements of a tuple is you put square braces after the name, and then you indicate what index you want. So if I want index 3, that gives me element, the 4th element. So that's 0, 1, 2, 3, because of 0 indexing. I know I'm hammering the 0 indexing point home, but like once you start programming, it'll come to you like pretty quickly, I think, because you'll just be making mistakes, and then you'll be making steaks. You'll be grilling them on your computer because your computer is going to be so hot from all the computer programming you're doing. No, you will make mistakes, forget 0 indexing, and then your program won't work. And then you'll be like, oh, right, I forgot. I need to 0 index this. It still happens to people like me. Don't worry. So, the elements inside of a tuple do not have to all have a uniform type. This is the case in some programming languages, but not in Python, not in snake language. So we can mix, integers, floats, other things like strings, and even booleans. We can mix all of these together into one data type, and you can get the stuff back out of them. Are tuples essentially arrays? So that's a more advanced question. Some of you that may be familiar with other programming languages will know arrays from other programming languages, like C, C++, or Java, I think, has arrays as well. So arrays are more basic. They have fewer features. Arrays are essentially... arrays are mutable. Tuples are not mutable. So once you've created a tuple, it's not possible to modify the elements of the tuple. So if I wanted to set hello to goodbye, I get a type error. Tuple object does not support item assignment. So with tuples, once it's created, it's set in stone. Basically, in order to modify a tuple, you have to destroy the old tuple, use its contents to create a new tuple with the modification. Why is t at 2 hello instead of 2? Well, first of all, 9.2, I think you mean, because remember the decimal point. And also, it's because of 0 indexing. So if I accessed element 0, I get 5. If I access element 1, I get 9.2. If I access element 3, I get... 3 is true and 2 is hello. I did those in the wrong order, but you get the idea. So, tuples can have as many elements in them as you like. There is no restriction on the size. And most importantly, once you put things into a tuple, they stay in the order that you put them in. You can also assign tuples to a variable. But yeah, so to answer your question about arrays slightly more, underneath the hood, that's how Python is storing tuples and lists. It's controlling the access to the array in such a way that it gives it certain properties which are useful, like, for example, not being able to assign anything to it. Now, you may say, how is it useful to not be able to assign something to it? And it's like, well, it gets into memory issues, which are kind of complicated, so we'll just leave them to the side for now, and we'll talk about them more when we talk about the difference between mutable and immutable data structures. So, operations on tuples. As I've already indicated, if we use square braces, that allows us to retrieve the i+1th element of a tuple. I've already demonstrated this a bit. But let's say we had a second tuple. So u is equal to 6, 7, 8, 9. You can concatenate two tuples using plus. The technical term for taking two data structures and jamming them together to form one larger data structure is concatenation. Yeah. No, this is the second element, because the first element is 5. It's 5 is the first element, 9.2 is the second element, hello is the third, and true is the fourth. So when you use index 0, you get the first element in the data structure. Shouldn't 2 be potato? No, because I put it in as hello. It's potato in the slides. Yeah, if you took if you took the second index of this, you would get potato, but I put hello instead, so that's what you get. So, if you want to take the length of a data structure, it's very, very easy. You just use the len function. So this allows you to see how many elements there are in your data structure. You also have a test for inclusion. So let's say we wanted to know if let's say we wanted to know if 8 is in U. You just say 8 in U, true. 12 in U, false. So this is just, it's a test for whether or not X is in the data structure. You can, of course, also reverse that, say 12 not in U, correct. Incidentally, this is the exact same thing as saying not 12 in U. But yeah, there you go. Good. Any questions about that so far? How would you access the new tuple once you've added them? Oh, you mean concatenated them? Well, you have to store it to a second. You have to store it to a second location. Well, actually, I don't think you do. You could just say t plus u at 6, and that gives you the correct element. But probably a better way of going about that would be to store it to some secondary location and then access the elements from that. That sort of keeps it... That minimizes the amount of work that the computer has to do, especially if you're going to be reading more than one thing from it. You don't want to have to perform the concatenation operation each time, right? So, is there no way to change the value once inside a tuple? Correct. You can. So there is a way of doing it, and it uses slicing, which isn't something that we've talked about yet. But I'll show you what the code looks like just in case, in case you're interested. But so let's say we had a tuple that was a bit longer, right? Let's say we wanted to remove the 5th element and change it for something. So what you would do is you'd say z is equal to t from the beginning to 1 minus the from the beginning to the element you're trying to destroy. Concatenate that with a singleton tuple containing the thing you want to replace it with. So let's say potato. And then concatenate that with the rest of the thing to the end. And that eliminates the thing at index 5, replaces it with something, and stores it to a new tuple. Right? So you can, in fact, reassign this expression to the same variable name. So it looks like you're modifying the tuple, but you're not actually. You're creating a new one and overwriting the old one with it in its entirety. That's the big difference between a mutable data structure and an immutable data structure. With a mutable data structure, you can overwrite individual elements of the data structure. With an immutable data structure, you have to destroy the entire data structure itself and recreate it in order to get the modification. So, like, it is possible, and I guess I'm being a little bit pedantic when I say that it can't be modified, because you can always destroy it and recreate it with the modification, and that effectively looks like modification, but from a sort of, from a strictly rigorous standpoint, you're not modifying the data structure, you're creating a new one that's mostly comprised of the old one. So this one is immutable. That's correct. This one is immutable. We're going to talk about mutable data structures next class if we get through all of this. Good. So I already talked about zero indexing. Yup. And yeah, we've already talked about how you can't assign to these things. So, like, if you were to, like, if this were a list, you'd just be able to say, you know, you'd just be able to do the assignment and it would work. But, yeah. And this fact particularly is why generally I prefer lists to tuples. So, you know, the question then might arise, why would anybody use tuples then if they're less convenient than lists? And the answer is efficiency. Because they're immutable, they're more fast and efficient than the mutable data structures, which have to be dynamically allocated. And if you don't know what dynamic allocation is, take 1xc3. But basically, if the amount of memory a variable takes varies at runtime, so it's not predetermined before the program compiles, but it's determined as the program is running, that's called dynamic allocation, because dynamic sort of means as it's running, and that is much more expensive for the computer than static allocation, which is what tuples do. But you know, so it's like it's an efficiency thing, but like this class largely isn't concerned with efficiency issues because we're really just, you know, getting started with things. I always take the position, though, that even though we're not necessarily worrying about efficiency during our assignments when we're writing assignment questions, it's still important for you to be introduced to the idea here. Okay? But anyway. So let's talk about strings. Strings, you've seen a couple of them before. Potato is a string. Yep, is a string. Basically, a string is a collection of characters. With each character, basically, strings are analogs of tuples. They share, actually, many of the same properties. It's just, rather than have each of the individual elements be anything, each of the individual elements is a character, as typed on your keyboard. Are strings immutable? Strings are immutable, in Python at least. So, if we have a string, say, hello, world, they are analogous to tuples in that the same operations can be used on them. You can take the length of a string. You can smash two strings together. Let's say t is equal to boy s plus t. Hello world, boy. See what I mean? Like all of these operations on tuples can also be performed on strings, including searching. So E in S, true. Good. We consider these guys to be literals. So in the same way that we consider 2 to literally represent the number 2, we consider, you know, the string far-fetched to literally represent the string far-fetched. You should kind of, like... They're kind of weird because, like, you sort of think of them as indivisible until you start operating with them. Then you can, like, pull in the divisibilities, but, and you can start working with them, but, yeah. Are they zero-indexed, like, tuples? Yes, everything is zero-indexed. Anything that has a numerical index like this is zero-indexed. In all programming languages that you are likely to use ever. With certain rare exceptions. So, in Python, you actually, it doesn't matter whether you use single or double quotes here. Oh, except, well, actually, this has been an excellent example. So, you can use either single or double quotes to delineate a string. What happened here, which was kind of an interesting example, it says, okay, I'm opening with single quotes, I'm closing with single quotes here, so what's this mean? I don't know. Syntax error, right? So if your string contains double quotes, you should use single quotes. If your string contains single quotes, you should use double quotes. But aside from that, it doesn't matter whether you use single or double quotes in Python. I thought strings were objects, or is that only Java? Well, yeah, no, like, in object-oriented programming, you also consider literals to be objects, right? So the to literal is an object, right? It just may or may not have any methods. Certainly, strings are objects which have methods. And, like, tuples are also objects, but, you know, we're getting into it. Do I have a personal preference? You bet your bottom dollar I have a personal preference. I have a strong preference for double quotes. Despite the fact that you have to hold shift to get them, and I'll tell you why. It's because Python is stupid, that's why. So, every single programming language except Python recognizes a difference between strings and characters, right? So in C, if you have a single character, just one character, it's always enclosed in single quotes. Because it's not a data structure, it's just a single character. Strings have double quotes, and in C, they always implicitly have a null terminating character which is never printed on the screen, but if it isn't there, then none of the functions work. So, like, the double quotes mean a data structure that contains characters, and, like, the characters themselves are single quoted in languages other than Python. In most languages other than Python. So, like, what Python is doing is it's confusing the data structure with the things the data structure contain, which is dumb and just confusing. It's not possible to write a single character in Python. It's like, if you've got quotes, it's a string, even if it's only one element. And it's like, there's no character in Python. Everything that you think is a character is just a singleton string, which is, like, so annoying. It's very annoying. Because, you know, characters on, like, underneath the hood are just numbers. Like, we're gonna get into it a little bit later on, but, like, there's a big chart where every character on the keyboard maps to a number, and you can actually view the numbers of the different characters by using the ordinal, by finding the ordinal number of the character. So you can see, like, lowercase z is 122, uppercase z is 90. These are, like, the actual numbers that your actual frigging keyboard sends to the computer when it says, I have a key press. These are the actual numbers that are being passed around, okay? And it's just like, anyway, that's one of my pet peeves about Python, is that they confuse they confuse the distinction between characters and strings. It's ASCII. Yeah. Anyway, so yep, we already talked about that. Ooh, there is one important thing, though, I should note about strings, and that's escaped characters. So not all of the characters that you might want to put in a string kind of work as characters that you would put in a string. Like, for example, what if you wanted to put an enter, like a press of the key return or enter into your string? Well, it's like, hello, world. And if you print that, you get the enters entered. So essentially, when you use the backslash key, and then put another character there, you can get access to a whole bunch of like hidden characters. And one of the types of hidden characters that you can get access to is actually quote. So you can actually use double quote in a double quoted string, which is, you know, how it's done in most programming languages. But in Python, you have the option of using single quotes as well. You also have tab, which is, it doesn't show up if it's at the end of the line. Come on. So backslash T inserts a tab character. So you can, you know, you see how it highlights all at once? It's not spaces, it's a tab, right? When you're a programmer, you have to worry about things like the differences between 8 spaces and a tab. Aren't you glad you're taking a comp sci course? But, yeah. So, and this is because each one of these things, like, essentially, something like tab or new line, like, you type it as 2 characters in the string, but it's only represented as one single character in memory, and it's printed out like it's a single character because it's like an enter, you know? But anyway, so what types of letters can we use in our strings? Historically, most languages only allowed for ASCII characters. ASCII dates from the 1960s and were originally used in teletype machines. Teletype is like some of the very early electric typewriters. Back then, each character was represented by 7 bits, so you only had 128 possible characters, which is, you know, if you include shift functions, that's about as many, that's a little bit less than the number of keys on a keyboard. So this is an ASCII table. Characters 0 through 31 were various types of control characters. Some of them are very interesting, actually. Then you have symbols, digits, and upper and lowercase Roman letters. So you've got some very interesting ones in here that definitely, like, these codes have not changed since the 60s, despite the fact that many of these functions no longer work in the manner you would expect. Like, a good example of that is carriage return, CR. So, when you're on a typewriter, like, that the carriage is the part that holds the paper that moves, like, to the left or right, one of the two. It moves as you're typing, you know, so that the words are being, you don't have to move the type head, right? The position that the sort of the hammer that strikes in the letter doesn't change, but the paper is moved, right? That's the carriage. So at the end of a line, you hit carriage return, and the carriage returns to its initial position, which means that you start right back at the beginning of the line again, right? So all modern computers, in the encoding for, you know, the computer and the keyboard, etc., all of them still carry this carriage return symbol, which is largely not used anymore, except in certain instances. And, you know, bell is another one, because, you know, in a lot of in a lot of typewriting, like typewriters, the old ones especially, there was like a little bell that would ding when a carriage return operation was complete. So it's like ding, and then you could start writing again. Because like if you hit a key while the carriage was returning, you would like smear and probably rip the paper. So you had to wait for the carriage to return, and the bell was like a indication to the typist that the carriage had returned, and it's, you know, you can continue typing. So like all these kind of symbols and all of these different functions and codes are still like not exactly in use today, but the for legacy reasons, it's kind of like how QWERTY keyboards, like the QWERTY layout hasn't really changed since the first typewriters, and not because it's the most efficient keyboard layout, but because there's no, like, the amount of work it would be to change keyboard layouts is generally more work than you would derive benefit from having changed to, like, Dvorak or something like that. By the way, if you don't know what a Dvorak keyboard is, Dvorak is alternate keyboard layout where the most commonly used characters are on your index finger and your middle finger. So, like, those are your fastest fingers, so in theory it speeds up your typing. But, yeah, can I pull up a picture of a Dvorak keyboard? And it's like, yeah. Yeah, here's a Dvorak keyboard layout. So it's like, or is it? Yeah, that would be it. So in theory, this, like, gets you a little bit more speed, but, like, you know, like, all of the commonly used, like, good letters to guess on Wheel of Fortune are mapped to the home row and stuff like that. But yeah, no, it's, anyway, getting a little off topic. Characters, very interesting. So, ASCII didn't have enough spots to represent lots and lots of characters, right? Characters with accents or characters from other languages, basically, ASCII didn't support them, which is, you know, the legacy of that continues to this day because despite the fact that programming languages are used all around the world by people from all around the world, pretty much all the keywords are still in English. I thought you were referring to the composer. Yeah. Yeah, no. So, essentially, the number of characters that you have available is limited by the number of bits you use to represent the character. So, 8-bit only supports 256 characters. But if you increase that to 16-bit, you've basically got more characters than you will use in many human lifetimes. So, this is called Unicode. Unicode is an international standard that specifies characters in hundreds of languages, and in fact, all emoji are Unicode characters. So, if you take a look, basically, you see how each one of these has a code after it? These are the Unicode codes in hexadecimal for each of these emoji characters, right? So, you know, so if you were wondering how emoji work, this is how they work. They're basically just an extended character set with a bunch of smiley faces. Yeah. So you just learned what emoji are, actually. Anyway. There we go. Yes, everybody put your favorite emoji into the chat, please. So, all Python 3 files are UTF-8 by default, so you do not get access to the extended character set, which means that you... At least for what am I saying? You don't get them for, like, variable names, but you can actually put them in strings. So, for example, let's say, and it also kind of depends on whether like the thing that you're printing them on actually renders emojis. There we go. That's a lot of emojis. There we go. So print UD83D. Nope. Yeah. Anyway. But yeah, you can actually if you learn how to insert arbitrary Unicode into like any like text interface on a computer, you can actually insert like emojis and other characters that aren't supposed to be there, which is kind of fun. But I'm not sure how you would do that here, for example. But yeah. What's my favorite emoji? I like monocle guy. There we go. That's my favorite emoji. Yeah. So anyway. So we talked about that. I'm going to sneeze. At least I thought I was going to sneeze. Anyway. So, in general, the operations that you can perform on strings are the same as the operations that you can perform on tuples, but here are a few more of them that you may be interested in using. So, for example, string slicing, or slicing in general, is an extremely useful and versatile operation if you know how to use it correctly. So, where's my terminal? Did I close my terminal? What a silly thing to do. Right. So, let's say we had an opinion. Pokemon Sword and Shield were the worst games in the series so far. Opinion. There we go. So let's say we wanted to take this string and chunk up, like, let's say we wanted to get everything between index 7 and 26. You would say opinion from 7 to 27. You can also, like, so this is kind of an extension of the syntax for accessing a single element. The key here is the colon, right? So you can also get from the very beginning of the string to any particular element, well, 1 minus any particular element, actually, by just leaving the first one blank, and you can get from any element to the end of the string by leaving the second blank. The idea, like, you should think of this as a blank here. In fact, you can also determine how many it counts by. So you can get every other element by indicating 2. You can get every third element by indicating 3. And another interesting thing that Python does with respect to indexing, and this applies to all data structures actually, it allows negative indexing. So you can actually get the last element of a data structure by indicating element -1. -2 is the second last, -3 is the third last, etc., etc. And here's another little trick. You can completely reverse a data structure using slicing by just going from the beginning to the end, indicating the step as -1. So that's like your quick hack Python way of reversing something quickly. You can also use reverse. somehow. I think it might be in the library somewhere. But yeah. Pokemon Legends is pretty good so far. Don't ask how I know. I mean, here's the thing about Pokemon games, right? Like the first, say, 10, 20 hours of any Pokemon game is good, right? Like, very good. The problem is, like, increasingly, they just get, like, super boring, like, after that. It's terrible. Could you replace one of those indices in a string? No, because it's an immutable data structure, I can't do something like that. String object does not support item assignment. Same as a tuple. Okay? Oh, looks like we're out of time. Are there any further questions? If there are any further questions, please indicate them in the chat now. Otherwise, I've got my office hours after this class, so if you want to come to office hours, that'll be good. But yeah. Raf os seres et ni samag tro ech eru dleish dna dros nomekop. Are the office hours on Teams? Yes. So, will the classes start in person next Monday, and where will they happen? Well, that's the question of the hour, isn't it? Oh, one technical question before I answer that. The double colon is like first argument blank, second argument blank. So it's taking, so it basically it's you take from the beginning and you go to the end. So it combines the from the beginning and to the end of these two. So there you go. Will the classes start in person next Monday, and where will they happen? The university seems pretty serious about classes starting up in person next week. I have not received any word to the contrary, and I'm going to be completely honest with you. I expected it. I did not expect them to actually go through with making classes in person. So our lecture hall next week will be JHE 376. Which I believe is the big one in the middle of the building. Let me see here. It'll be kind of exciting for you guys, because you'll be trying to find rooms on campus for the first time, right? Or for some of you, anyway. JHE 376 McMaster. Let's see here. That's not very informative, McMaster. Oh, here's a floor plan. My goodness. Yeah, so, essentially, JHE, right? So, this is the front of the JHE building. The Iron Ring statue is, like, right about here. This is, like, the main entrance to the building. So all you have to do is go into the building and take either this or that staircase up 2 floors to the 3rd floor, where you'll just, like, pop out here, or, like, in here, and just in there, and boom! So you actually, there you go. Bing, bang, boom. JHE. And that's a projection room, but we won't be using the projection room. So there you go. This is the lecture theater. Are we able to reset our assignments on Jupyter Hub? Yes. So, if you want just a clean, wipe, delete the whole folder from the directory view that you get when you first log into Jupyter. If you delete the entire folder, you'll be able to refetch the assignment like you'd never fetched it the first time. So that's a way that you can blow everything out and reload. Personally, I would, save your work so far somewhere else, but yeah, that's the process. Like, that'll delete all of your progress so far, right? So save it somewhere else if it's useful or important. Will in-person classes also be recorded? Yes. So my wife got me a camcorder for Christmas, and I'm paying TAs to video record the lectures, and I will be posting those to the YouTube channel. So yeah, we will continue to have recorded lectures after the move back to in-person. So if you're, it's kind of a universal design for learning thing, some people really need recorded lectures, so they'll still be able to get them. Any other questions? If not, I'm going to sign off here. The lectures won't be live streamed, right? No, the lectures won't be live streamed. I would be very hesitant to try to live stream the lectures over McMaster's Wi-Fi. Although McMaster's Wi-Fi is pretty good, you can't stream over Wi-Fi. It just doesn't work. We're not. They're not going to be live streamed. They're going to be posted as videos after the fact. Yeah, if you want to get the lecture content at the time that the lecture is occurring, you have to come to class. Peace.